In this video we'll look at trig graphs. Now to start off, we're going to learn how to draw the normal sine graph, and for drawing it, what I do is I always remember that sine goes up to 360. If we restrict it that way, or the first period just goes up to 360, and then I halve that, then I get 180, half that, that's 90, and then between 180 and 360 we've got 270, and then sine only goes up to 1 and down to -1. Now to draw it, just remember that we start here and then we draw it over 90 through 180, underneath 270 and 360. So this you have to learn off by heart, how to draw your basic y equals to sine x. Then if we go over to cosine graph, we also start at 360, half that, and then half that, that's 90 and 270, and then cosine also goes up to 1 and down, or from -1 to 1. When you draw these in, you can also it's your choice how you want to remember it. You can also just remember the quadrants 90, 180, 270 and 360. Now for cosine, we start at 1 when we draw the graph, then we go through 90, underneath 180, through to 70 and over to 360. And then for the tangent graph, I mark off my domain as 360, 180, 90 and 270, and then we also indicate our values at -1 and 1. And then what's important is the tangent is undefined at 90 and at 270. So to start drawing it, we start here and then we draw it up, and then we can start drawing it up again here and down, and then also down here. Right, so to look at the basic graphs, we have our sine graph, our cosine graph and tangent graph, and it's extremely important that you know how to draw these three off by heart, because when we are like we are going to do now, we're going to include parameters and see how they affect the graphs. And when you draw your graphs, you always start with the basic graphs and then apply your parameters by shifting it or stretching it, etc. Now to look at the periods of the graph, we see that the sine graph repeats itself every 360 degrees. So therefore its period is 360. So the period basically tells you after how many degrees does the graph repeat itself again. And then we have our cosine graph, and then after 360 degrees, so the period is 360 degrees, but the tangent graph repeats itself after every 180 degrees. The same thing happens after every 180 degrees, so its period is therefore 180 degrees. Now to look at the domain of these graphs, if we restrict these graphs from 0 to 360, now the domain is also dependent on how your question restricts the graph, because these graphs actually go on to positive infinity, to the right and to the left, negative infinity, but the question always or mostly restricts the graph, and in our case we are just restricting it to run through one period. So we have our domain starting from 0 up to 360, and then same for the cosine graph, we are starting from 0 to 360. Remember, the domain is your x values, or where the graph has x values. And then for the tangent, it's slightly different. Since 90 and 270 is undefined, it does not form part of your domain. So your domain will therefore be from 0 to 90, not including 90, but are including 0. And then from 90 to 270, not including them. And then from 270 again to 360. And then for the range, that's our y values. Now for our basic sine graph, it only goes from -1 up to 1. And then for the cosine graph, the same, from -1 up to 1. And then for the range of the tan graph, we see that it goes up to infinity and down to negative infinity. Therefore its range is just y is an element of a real. So it's all the y values. And now we're going to start looking at the parameters. So first of all, we start with the amplitude. Now we can see that when the amplitude, that's the a value in front of the graph, if that changes, the graph stretches up and down. And as you can see also, if this graph, if the amplitude is positive, it just stretches it up and down more. But if it's negative, then the graph starts to stretch downwards, or it reflects in the x-axis. So now what we're also going to do is we're going to have a look at all three of these graphs and how the amplitude changes them. And then further on, we're going to look at different parameters like our shifts. And for each of these, we're going to look at how the period, the domain, and the range is affected, and if they are affected. Now, to start with the period, and for all of these, let's assume that in the future of this video also, that all our graphs, we restrict our graphs from 0 to 360. Okay, and now, as we can see, our period remains unchanged when we adapted the amplitude's value. So now let's just draw a graph. Let's say this graph goes up to 2 and down to 2. That means my A value is 2, and my domain will still run from 0 to 360. So my x is still an element from 0 degrees to 360 degrees. So my domain remained unchanged, but what changes is my range, because when the amplitude changes, it stretches, and therefore it goes from -2 up to 2. So my y now is an element from -2 up to 2. Alright, so now let's look at the amplitude when for the cos graph. Now it stretches up and down as your A value changes, and then it goes over to a negative, then it stretches down, so it kind of reflects. And if we should draw a graph where we restrict it from 0 to 360, we see it still goes through these same intercepts, goes up and then down. Then what happens, our period, it remained the same, it's still 360. The domain also same, x is still an element from 0 degrees up until 360 degrees. But if our A value is -3, it means it goes down to -3 up to 3. So our range, y is an element, it's from -3 up to 3. That's our new range now. And now for the amplitude of the tangent graph. Once again, we can see our period, it doesn't change, it's every 180 degrees. The graph repeats itself, so it's still going to be 180 degrees. The domain also, if we restrict our graph just from here, from 0 to 360, it still didn't change the domain. So x is still going to be that element of so it started, if we restrict it here and over at 360, we had that it starts from 0 including 0, go up to 90 not including 90, or it's from 90 degrees to 70 degrees, or it's where it's from 270 not including 270 up to 360 including 360. And then also our range also unaffected, because it was from negative infinity up to positive infinity, so the range still simply is y is an element of a real. And then if we look at the vertical shift, what happens is this is our q value, and if we have a q value, it shifts our graph up or down. So if the q value is positive, it shifts it up. If the q value becomes negative, the graph goes down. Alright, so now let's assume that our q value, now our new q value is -1. That means our graph has been shifted down with 1 unit. Now once again, our period, we can see the period remained unchanged, 360 degrees. The domain also unchanged if we restrict it from here to up to 360. This would be over here. So the domain is still where x is an element from 0 degrees to 360 degrees. And then the range is, well, what has changed. Now if we have minus 1, if we moved our graph down to minus 1, that means that this turning point over here is now lies at minus 2, and this one lies at 0. So therefore our range y would be an element from minus 2 up to 0 if it shifted down 1 unit. And then to look at the cosine graph, if it shifts up and down, once again our period remains the same. It's if we restrict it, well, it's still 360. And then the domain also, x is the element from 0 up to 360, and then the range. Now let's say we draw a graph where we've restricted it, but now we're going to take it, we're going to shift it. Let's make q equal to 1. So if we have q equal to 1, this is now our new axis, or not, well, we can't call it axis, but this point which did go through 1 will now go through 2, and then next the one that goes through 90 will now go through there, and then we have 180 over here and 270 going through here again. Let's just make this clear, and then finally the 360 will be at the top. So now our graph will look like this, more or less, if we restrict it, and that means that our range is now from 0 to 2. So y now is an element from 0 up until 2. And now for the tangent graph. So q value, just moving it up and down, does not change our period. It does not change our domain. That is still the same. And then the range also, y is an element of a real. That also remains unaffected. And now we have a horizontal shift. So look at this p-value, it shifts it to the right. So if we have a p-value over here, it shifts it left and right. And if this p-value is positive, this p-value being positive will give our equation x minus a value. So in actual fact, if we look at the equation and we see x minus p, it's actually moved to the right. And if we substitute in a negative value for p, where p is negative, it shifts it to the left. But if we substitute in a negative value of p, it's going to make this a positive, because it's going to multiply with this negative. And then in actual fact, if we see sine x plus p, or plus our value, it means the graph has shifted to the left. And now let's see what happens if we have shifted our sine graph. The period will still be 360, unchanged, but the domain is the one that's going to change now. So if we have, let's say we've got p is equal to minus 90, that means we shift our graph 90 units to the left, but our equation will look like this. It will be sine x plus 90. Okay, and then our domain, if our domain was restricted from 0 to 360, it will now, see 360 is over here. If it was restricted from 0 to 360, the domain will now shift with 90 degrees. So that means it will now be where x is an element from minus 90. If it was at 0, it starts now at negative 90. And if it was at 360, it ends now at 270. And then for the range is unchanged. The range is still an element from negative 1 up to 1. And now to look at the shift for the cosine graph. So let's say that our p-value, let's say we move our p-value with 30 units to the right. So our period, once again, is still 360 degrees. Our domain, the domain is now the one that's going to be affected. So if our domain was from 0 to 360 in the original graph, if we shifted 30 units to the right, and our equation will look like y equals to cos x minus 30, so going to the right, we have where our domain is now x is an element of 30 degrees up to up to 390 degrees. And then range stays unaffected from -1 up to 1. And then for the horizontal shift on the tan graph, we've got our period as 180 still. And then once again, the domain will change. And for another example, we can say that our p-value is, let's say it's 100. So if we shift it from 100, and let's say that our original graph was just this actual graph here from 90 to 270. So what will our new domain then be? If we shifted p to the right, 100 units to the right, then our new domain will be where x is an element of 190 degrees up until 370 degrees. And then once again, our range is unaffected. It's still going to be an element of a real, going from negative infinity up to positive infinity. So now we have a frequency, the k value. Now the k value stretches the graph, as you can see over here. If the k value becomes bigger, it actually stretches the graph out more. And if it becomes, if the k value is bigger, it shrinks the graph. But if the k value is smaller, it's a fraction, then it stretches the graph. So now this is where our period changes. And how we can work out the period is with the following equation. Our period for the sine graph is the original period divided by k. So whatever your k value is, if you want to find the period, you simply say 360 divided by k, and that would give you your new period for the graph. And then for the domain, let's just go back there. The domain will also change, because it's also going to, if our normal graph was from 0 to 360, and let's say our k value is 2, then the graph shrinks to half its domain. So if our normal sine graph was up to 360, it will now look something like this, where it is now it's been shrinked to the inside. So that means our new domain will then be where x is an element of still from 0, but now just up to 180 degrees. And then the range that's unaffected, our range is still from minus 1 up to 1. The frequency does not affect the range. Right, and then here we see how it happens with the cosine graph. It shrinks as k becomes, and then as k becomes smaller, it stretches it out. Right, now for the period, once again, you use the same formula. You say 360 over k to find the period, and then the domain. So let's actually, we'll look at a few examples later. And then for the domain also, if we had k being equal to a half, then that means that our period is going to go up to 720. So then our domain will be x is an element from 0 degrees up to 720 degrees, and then the range is unaffected. Y is the element from -1 up to 1. And now for the tangent graph, this is what it looks like if it stretches and shrinks. And once again, our period, now to find the period, because the tangent graph's original period is 180, to find the new period, we just divide k, or 180 divided by k, and then the domain will obviously change. It will, so let's take 3 for example. If we have k equals to 3, then it will shrink the graph, and where our period will then be equal to 180 divided by 3. So this will give us 60 degrees. So then the domain, if we had restricted from 0 to 180, let's say that was our original, then our new domain will be where x is an element from 0 to 60 degrees. That's if the original just went up to 180. And then the range is still the element of a real, not affected. Now let's look at the question being asked as state the period of each of the following functions. And we have sine 3x, and therefore we have the k value. So k value is equal to 3, and then we're going to use these formulas to find the period. So a period is then equal to 360 over 3, and therefore our period is 180 degrees. Or we can be asked to find if x equals to tan x over 4. I'm just going to rewrite it as tan 1 over 4x. Then this is my k value. So k is then equal to 1 over 4. And to find the period, I'm going to say 180 over k, because tan's normal period is 180 degrees. And then to do that calculation, we say that 180 over 1 over 4, and then we can put that into the equation. So we have calculator divided by 1 over 4, and that is equal to 720. So that's equal to 720 degrees. Or we can be given the graph. That means we're given the period, and then we need to find the k value. So we can see this is the cosine graph, and it goes from 0, and then 180 it starts to repeat it again. So therefore its period is 180, and we're going to use this equation again, but we're just going to isolate k. So k therefore is 360 over p, where we take the k up and we bring the p down with cross multiplication. And then to substitute in the p value, we've got 180, so 360 divided by 180. So now our k value is 2. So this would be cos 2x. And then we move over to this one. Over here we see that this is our sine graph, and it goes over up to 450. But remember, the sine graph, if we complete it, the completed sine graph looks like this, where it goes like this. It goes, well, let's say this is an example. So we've only got this part over here, which is this part, and our normal one actually goes up to 360. So this will then, if this is 540, we have 540 times by 2, because that's just a half of it. 500 times by 2, the complete period is 1080. So our period here is 1080, and therefore our k value is 360 over 1080, and that will give us 360 divided by 1080 is equal to 1 over 3. So our k value is 1 over 3. And finally, just the summary of all our parameters included. We've got our amplitude, our frequency, our vertical shift, and then that's the horizontal shift, and then the vertical shift for each of the functions.